Hello everyone. Welcome to today's AI seminar. Before starting this, I request everyone to please turn off their mics so we don't have the background noise. And also, if you have any questions during the talk, you can just uh, type your questions in the chat box, and we'll try to get them answered by the end of the talk. And lastly, we'll be giving away a $50 Rosso gift card to one of the lucky ones through a draw. So stay tuned through the through the seminar. Okay, so with this, I'll introduce today's speakers from CloudML and SpringML and Google Cloud. So Masaf Dawood and Sindhu Adini will be speaking from SpringML. Masaf is the Director of Cloud Services for SpringML in Canada, and he's a technology leader with over 20 years of experience in technology strategy and management. Sindhu Adani is the Director of Cloud Services at SpringML with focus on solutions in healthcare and life sciences space. Chloe Tottem, another speaker, she is the higher education cloud manager at Google Cloud with primary focus on helping higher education institutions in Western Canada to benefit from their tools and services for education and research. With this background, I'll hand over to our speakers to take the stage.
Thanks, Niraj. That's great. And thanks for the introduction. So yeah, obviously I'm Chloe Tottem. I'm sorry my video doesn't seem to be working. I think I'm frozen, so you can kind of see a frozen version of my face. But I represent Google Cloud for Higher Education, and I'm essentially the U of A to Google conduit. So my goal is simple. I support research on Google Cloud platform. Sometimes I actually refer to my job as a movie producer, but for science projects. So basically I help find resources within Google to enable your projects. And chances are that somewhere, someone at Google is interested in the questions that you're trying to answer. So with that in mind, I just wanted to kind of jump into a few, a bit of a high level overview of like kind of why Google Cloud, what we do differently that others don't, and then we can get to the science side. So to start off with, compute. So we're kind of known for our cloud platform. We have flexible compute offerings. So essentially you can slide and decide the number of cores, amount of memory, right sizing recommendations. So basically efficiency is of paramount importance to us and our customers. Secondly, security. Everything about the way that we design our platform is built with security in mind. So each server has a Titan chip, which makes boot impossible without the cryptographic, like unique identity that it creates. And also data is encrypted at rest by default as well. So then the next part is where it really gets down to and interesting for the research side. We have a major open source focus at Google. So if you look at any kind of major open source project for distributed computing or data analysis, it's likely that Google was a major contributor of that. And we make it easy to use the open source tools that we have. And we offer like managed services based on these tools across the board. So things like MapReduce, Hadoop, Apache Drill, Kubernetes are just a few examples of the open source kind of projects that we've been involved with. And then lastly, providing the latest hardware to researchers. This is a big one. For us, it's imperative that our customers, of which, there's a lot of healthcare life sciences researchers, have access to like the latest hardware. And most of the time we're testing hardware at scale before the public even knows that it's coming available. So for example, A100s were announced in May, but they were available on GCP by July. Same for T4s as well. And also with using Google Cloud, and something that I think might be quite relevant to the Amy researchers and fellows, zero net carbon emissions when you're using Google Cloud services as well. Oh, sorry, next slide, please. Thank you. I forget about that. So here is just a brief overview of our main infrastructure components. So just starting from the left, the compute, which I've already touched on, really fast to deploy, easy. You can create custom configurations. You can create machine images as well, which kind of helps with orchestration, being able to boot up multiple machines very, very quickly. We also, something that's very interesting for our research community is the preemptible instances that are available. And these are really popular because they're 80% lower cost, and you have access to GPU, TPU instances as well. And it's essentially for short-term compute bursts. So if you want, it's great for data processing, any tasks that you just need some compute to push at it. Then moving on to the storage side, Google Cloud Platform offers kind of various storage offerings. So it depends on what you're trying to do, and you can mix and match what you want. There's persistent disk that is essentially block storage, similar to what you probably use on an OpenStack cloud or something like that. And that can be used by the compute engine and connected to the instances. And then there's just for pure data, there's blob storage, cloud storage that can deliver kind of what you need and scale pretty fast. And then there's also cloud data store, which provides near infinitely scalable, schemaless solution for storage as well. So that's just a really high level overview of that. The networking side of things, we have a privately managed network infrastructure that's actually one of the largest in the industry, and ensures that the information and applications are the least exposed to the public internet and its inherent risks. And on top of that, we can also offer VPC service, so you can create your own virtual private cloud and control it how you want as well. So there's a lot of security parameters that you can put around your resources there as well. And then HPC partners. We have a really strong ecosystem of experienced service partners, solution integrators to help implement, even the strangest, weirdest, toughest workloads. We've pretty much got someone that can do the job. And then lastly, this is democratizing supercomputer is a term that we use quite a lot. So the idea is that we want, to have easy access to fast compute, rather than spending 5 years building the next Summit system or Niagara system, unless you actually want to. So not everyone needs that power. So this graph here is just a good representation of, what we can do to help you find the right solution, stretch your grant dollars, and publish faster. Next slide, please. And then just to kind of give you a bit of an overview of Google Cloud in Canada, I'm actually part of the Canadian team, as is Frank and Mike, who's also on the call. So we actually have a Google Cloud platform in Montreal with 3 zones within it. And we've also got a Toronto region coming as well. The Canadian team at Google Cloud is actually very aware of the regulatory requirements when it comes to PHY and PII data. So, we can make sure that we satisfy data residency requirements very easily and transparently by specifying the instances and storage reasons, remain in Canada, and you can do that from the console. We also have Protection B status to work with federal government data as well. And we've established all the necessary Canadian-centric framework to support this. And then on a final note, we also do have a life sciences and a healthcare API, which has proved to help protect like healthcare data while meeting industry-specific security, privacy, and compliance requirements as well. And I'm happy to go, I think we're going to be going further into that in Sindhu's piece. So, and then just lastly, we really just aim to bring and form a supportive partnership with research within institutions. You know, I'm based locally, well, Calgary, which is somewhat local, 3 hours down the road, I suppose. But we want to provide like tailored training, research credits where needed, which, you know, I'm more than happy to speak about. We provide up to $5,000 worth in research credits just to get you started. And then also professional services engagements just to help, you know, understand how to use the cloud or launch a project easier and faster. And then that kind of brings me to my last point, really. You know, jot down my email and please reach out to me. I'm more than happy to talk to you about research credits, training, or any opportunity to collaborate. So yeah, let's have a chat, and I'm going to hand over to Masaf to do a brief introduction on SpringML. Masaf.
Thank you, Chloe. Appreciate it. And many thanks to Professor Russ for giving us this opportunity and leading us here, and Neeraj for the intros, and Sabina for the coordination. Very much appreciated, folks. Just wanted to mention that on the call we have Frank as well with us. Frank and Mike from Google. Frank is one of the, I'd say, thought leaders in Google ecosystem within Canada and US. And certainly very, very experienced in multiple types of opportunity solution sets and industries. So I just want to bring that up. So in terms of any potential post webinar Q&A, I think that would be very, very helpful. So just a brief overview about us. So we're SpringML. We're a Google focused status within Google for Premier Partner. Typically, I think our focus is on 4 special machine learning and data analytics, and most recently it has been application development. But the big theme that is,
I mean, Masaf, you keep cutting out.
Yeah, Masaf, you are breaking up.
let me go back here. If you can move a few slides back. Yeah. Is this better?
Yep.
Yeah, I was just giving us an overview. So we are a Google Cloud partner, which essentially means we work with Google Cloud ecosystem. We are by design focused on Angular Cloud, GCP. In terms of our focus areas and key expertise, we have 4 specializations: data analytics, marketing analytics, AI, machine learning, and most recent development. Thread and the common theme to all.
Masaf, you're breaking off, Masaf.
We'll hear about 30 seconds and then a 10-minute break, and another 30 seconds, another 10-second break.
I can Masaf, I can like continue like the rest of this. So like Masaf mentioned, you know, we have specializations. We are like premier Google partners, and we specialize in developing our platforms on Google, and primarily in the data analytics field, the marketing analytics, machine learning, and right now we are also we've started investing and doing a lot of application development. So we own that specialization as well. Again,
is this any better? Sorry, Sindhu, I'm back.
Yeah, this is better, Masaf. Go ahead.
Oh, sorry about that. Thank you. No, continue. I just want to make sure I'm back.
No worries. So again, this talks about our capabilities and how they align with all the specializations, right? Most of our we started off with the deep, machine learning and AI and the data analytics and visualization. And, we also partner with Google in some of the kind of beta offerings and products, like, for example, contact center AI and chatbot and custom app development is something that, we partner with Google, help them build some pre-templates and things like that. And so we kind of heavily lean on each other in terms of, delivering value to our clients. That being said, what we wanted to talk about here today is basically, how, researchers, as data scientists, you can have compute and data at your fingertips. Taking a step back, some of the challenges we constantly kind of hear in this particular domain is, hey, scalability, saying like, I have this ton of data and I want to bring in more data. How do I scale, right? How do I scale not just from a data perspective? How do I scale in terms of compute? How do you can always add a lot of machines to scale, but what is the ease of scalability? How do I scale from one cohort of researchers to multiple cohorts of researchers who, have now these grants and who can utilize and share the platform? Something that we constantly hear about is data sharing and collaboration. Peer reviews are so critical in this domain, but what is the ease of actually sharing the data and your insights with your peers, who may not be using the same platform? And then high compute costs, like you may not need compute, high compute 24/7, but you may need compute to run those very specific high compute tasks, which may just be like, a 15-minute or a 1-hour task. So how do we manage these compute costs by actually allowing you to pay per use, pay for the compute you use at that point of time, instead of buying the expensive hardware and software just for those compute cycles, which are not, which are not typically constant through it. And then when you take, those are like the bare minimum kind of challenges. But when you look at the other spectrum of challenges is like, okay, data harmonization, data standardization, how much work or how much manual effort is currently being spent by the team, by the researchers to actually do data engineering, data curation, data harmonization tasks, where the time could actually be leveraged to do higher valued work, like looking into the data, finding those insights, building the models, fine-tuning the models, right? And how do you take something as simple as, hey, I do this data curation for every new data set that comes in. How do I create a repeatable process that I do not spend the same time data set after data set, or pipeline after pipeline? And then the other piece of that is, now that you've figured out there is a repeatability, how do you automate it, not just from a data engineering perspective, but also from building those ML pipelines? How can I remove the manual effort, understand that there's repeatability, and then how can I automate that so that me as a scientist or a researcher can actually focus on the higher value tasks that I'm the insights that I'm actually working on right now? And then everything comes with integrity and data governance. So what does Google Cloud do, right? So we always hear about cloud technology. Hey, you can access anywhere, anytime, and things. But there are some true tools and services within Google Cloud. And I'm saying this because I actually come from an AWS background, and we've done this on AWS. But Google kind of just pushes the envelope so far that just the ease of doing things when it comes to research and ML and AI is phenomenal. So how do you reduce this friction? How can you build, train, and deploy anywhere, right? Models, data, imagine, and that's why we named this series as, compute and data at your fingertips. How can you build, train, and deploy anywhere? Google provides you the skill set to do so. Speed to productionalize it, right? You have this thing, you have a data set, you have your ML model. how can I get the peer review, get it tuned, get it hyper tuned, and actually productionalize it? What is the speed that it takes for me to do that today versus how can Google kind of help me get there faster? One great thing is ingesting and distributing data reliably. That's in the core foundation of any kind of services you see within Google. Data labeling, which is a key aspect. Many people, when they build research data platforms, they kind of do not pay attention to how do I label the data, how do I catalog the data and build a robust metadata catalog. But this is inherently built into the veins of the services Google has built around the data analytics. And then finally, not finally, but one of the key things is it's a unified, open, and fully managed architecture. What that means is most of the services that you see today are fully managed services. So you don't have to have or hire, your university would not have to hire like highly skilled staff in Google Cloud services for each of those services to be able to maintain that platform. Instead, Google does it for you, and it's unified, it's fully managed. And then your IT team would just have to interface and say, hey, I see these issues, or I'm able to view the compute, view the log, and kind of make recommendations back and forth. And then the key thing is really repeating data engineering and data harmonization processes, a struggle that I mentioned in the previous slide. That is possible with the toolkits and the services that Google brings to bear. That being said, what we believe is truly needed in order to, not just democratize the data, but allow you to overcome all the challenges that we looked at, is building that flexible and scalable research platform. And when we look at a platform like this, we think of it as, pieces of Lego blocks with some very fundamental pieces. You have data management, you have data exploration, and then you have platform management and security. Now, in the data management piece of it is where you basically show all the data and process all the data, ingest it, perform curation, engineering, harmonization, some form of standardization, and the pieces that go like, how do I bring in the data in the raw format? How do I curate it so I can do some kind of analytics to it? And then finally, based on what I curated and engineered, how can I publish it for further use or exploration, or I publish it to actually provide some business or business intelligence or business insights. Then we come to the data exploration and the intelligence and insights, right? This is where all the tools are all the consumers of the data set. And our focus today is on the analytics and the AI, ML, and data science. Where the representation of this box does not mean that you can only look at published data, but the representation of this segment means that you can access data in any of these layers, and you can define you can access data in any of these layers, and within the data management layer you can define, control, and automate the curation, the processes that move the data in the pipeline from each of these. So for example, AI and ML and data scientists, deep data scientists can say, hey, I just want pre-curated, I want harmonized data, all data that has a categorization of, say, male should be represented as M and female should be represented as F, no matter where the data set comes from and how it's represented in the raw. The moment that's done and stored in that curated layer, you can have the tools and the kits to actually, the tools and the access to that data to be able to do your analysis, run your Jupyter notebooks, further do some data engineering, and then it opens up. What we also provide as a part of, or what we also think about as a part of building this research platform is, how do you inculcate security in it? Because the first thing that we hear folks saying is, hey, if you're opening up this data to all the data scientists, like, I don't want to open up all the data to it. So, and this is where all the layer of data access, security, governance, and operations come into play, where you can define which data set has, which user has access to which data set, And if the user, performs further computation and is pushing the data back into this data management layer, what do those parameters of sharing look like? Can he share and open it up to everybody so that they can do peer reviews, or they can, use this data further? Or can he open it up to a restricted level of users where only a few users have access to the data he's further published? So this is how we envision like a flexible and a scalable kind of platform to help you overcome compute challenges. The reason why I say overcome compute challenges is you pay as you use. So if you have high, processing ML models over here, you can use compute only when the model is up and running. And then when the model is not running, the compute slows down and you're not paying for it. But it's also scalable in terms of you have an ingestion layer where you bring in lots of data. You can constantly build multiple pipelines through the stage to say, hey, now we are able to not just scale to 10 data pipelines, but I can further scale to 100 data pipelines. So this is kind of the core foundation in allowing researchers and data scientists to overcome those technical challenges. And now what we look at is, so these are basically logical and conceptual pieces, right? Now what we are going to look at is how does Google actually help you get there? So the Google ecosystem is huge, but here are some basic tools that allow you to actually overcome these challenges and overcome this friction. Some key tools over here, I'll just touch upon them here, and then I'll hand it over to Frank, who's very intimately familiar with these tools and can answer deeper questions. But some of the key tools here are like the deep learning VM, which is new and curated specifically for running those machine learning models that you are working on fine tuning, all the way up to AI platform, which is more of, hey, I'm not building or fine tuning a model, but I want something where, I have this visual representation of all these images, DICOM images, and I want to be able to quickly run something and, quickly train a model and give me a certain prediction or a certain outcome, but I'm not familiar enough to go and tune the model itself. Some of the foundational pieces is BigQuery ML. So BigQuery is, Google's the data warehouse, but BigQuery ML is key because there are those aspects of building the data curation and auto data engineering that BigQuery ML brings to bear. And then you have a host of data engineering tools like the Cloud Data Flow, Cloud Data Fusion, Data Proc, which allow you to build those pipelines based on the need. That being said, I'm actually going to hand it off to Frank, who is the Google's cloud data engineer and well-versed expertise in this, and who will be able to go in depth into the technical aspects of these services.
Cool. Thanks, Sindhu. Can you hear me okay?
Yes.
Excellent. So just to kind of extend out from what Sindhu was speaking to, the way I kind of look at the Google Cloud Platform, the way I describe it, I kind of slice it up across data science, but then also across data engineering. And when you look at data science, AI and ML, there is a spectrum there on the different type of researchers that tend to use the platform or different technologies. We have conversations with the folks at like the Vector Institute here in Toronto, where some of them are kind of interesting conversations where we talk about vision-based machine learning and some of the really cool tools which I'll talk about in that space. But that group of folks really want to spend their time kind of on the left-hand side of this slide. They're folks who are very much down in the weeds. They like that kind of micro-tuning elements inside of TensorFlow and PyTorch and stuff like that. So they prefer an environment where, they have complete and utter control over what variables could kind of go into the training of the model and even the deployment of the model where needed. So very much that raw end of machine learning research side of things. as you kind of, drift across to the right-hand side of this slide, what we're trying to do with the platform for data scientists is essentially give them, the ability to create models, but do it in such a way that it's, we're removing burden or removing friction from the process. So we're trying to make it easier as you go across. Now, as you drift across, obviously, some of the nuanced elements inside of the platform tend to change a little bit. Like, just as an example, with AutoML. AutoML is a tool or a platform, I should say, that Google has created to allow for, in a lot of circumstances, fast prototyping of machine learning models. Like, as an example, we've had folks look at diagnostic imaging and just trying to figure out, like, could AI theoretically do something with a set of X-rays of folks with pneumonia, as an example? Could it actually, if tagged correctly, we put it into the system, could we train a model relatively quickly to understand what's what? And then from that, those researchers began to kind of move to the left-hand side of this slide using the different platform to kind of dig in and understand a little bit more about how more specific or how more precise the model instantiation could help. There are other areas in here like Kubeflow, Kubeflow is more looking at machine learning ops, so ML ops, which is kind of grew out of DevOps and development operations. How do you train a model and then retrain a model, but then also deploy the model? Or if one of the situations that comes up with model creation is, hey, it looks like we've introduced some level of bias into this model. When does that look like that happen? Could you actually trace back, through the data as well as the models to try and understand what has actually happened there? So that's very important in areas around regulated industries, be it healthcare or financial services, as an example. One of the other ones in here that I'll dig into a little bit more detail is BigQuery ML, which essentially allows for data scientists and machine learning researchers to look at structured data within BigQuery, but then create models using SQL, which is, some people are a little bit, well, that sounds like a bit of a weird way of doing things, but essentially what Google is doing is allowing for some of the work that we've created with regards to model instantiation and just presenting it up through an SQL interface. So that's proved to be very interesting for folks that are looking at logical and linear regression type models, which kind of play into that space. We might move to the next slide. So the flip side of this is also around data engineering. So, as you guys are well aware, you can't really train a model without data, be it, structured data, image data, or other different data types. So what Google has built out, and this is something that actually has a lineage that goes way back before Google Cloud was instantiated. So things like data flow, which is essentially Hadoop, in the background, which I don't know whether you guys know this, but that grew out of MapReduce, which was a Google technology way back when. How do you create these data pipelines from wherever the data is coming from, be it in a single place or across multiple sources, and then shape that data? The acronym that's used is ETL, so extract, transform, and load, into a repository where you can actually start building models or deriving insights, from that data. So Cloud Data Flow is a very raw but very powerful tool. It's something that Google uses internally on a minute-to-minute basis with our large data sets. Cloud Data Fusion is kind of the next generation of that, which puts a more manageable front end to data transformation, data extraction. So it's something that's very UI driven. Cloud Data Flow tends to require, some level of knowledge around Java or different development code base. Data Fusion tries to remove that. So essentially, give me a connection to your database, be it Oracle or MSQL or other on-premise or in-cloud repositories. Tell me where you want to send it, so to BigQuery, say, in the cloud, And then let me step you through the wrangling process. So what columns need to be adjusted, removed, pushed together, all of those sort of things to get the data into a correct format. And then once that's created, that data pipeline is created, you can actually automate it. So if this is something where you need to stream the data in or go and get a batch, grab every hour or every day, you can automate both data flow and data fusion to enable for that. And then data proc is kind of that next, how you actually process the data. So it's essentially a Hadoop instances, which some people tend to use for their data management prior to kind of getting to a point where you can derive insights or create models from that. So we might move on to the next slide. One of the things, going back to that example I mentioned around the Vector Institute, and they're wanting to kind of have complete control over the libraries that are used, the versions of the libraries that are used, different frameworks that are at play. The Google Brain team essentially, they work on model optimization and all that sort of stuff day in, day out. They actually work to create it's actually a set of images, VM images, where you can actually go into Google Compute Engine and say, I want a system and I want to use the Google deep learning VM, and there's some options there, and it will actually build that out for you, and you'll have all of the core elements that are required for model creation or testing and development are built into that. And it's also built in such a way that the libraries are optimized for the underlying hardware. So we've got different types of GPUs that are at play. Sometimes those GPUs require specific libraries to optimize how they function. So if you go and choose, say, the NVIDIA P100 GPU or set of GPUs, we will make sure that the libraries that are required for that particular GPU are in place and loaded correctly. So a lot of the instantiation of your environment, we can actually just simplify that. And it also allows you, if you want to kind of move from one GPU to another GPU for whatever reason, be it for scale or there's additional functionality that's kind of introduced, you can quickly do that with these sort of VM images. So it makes it very flexible to get up and going, but it also gives you that landscape of environmental landscape inside of the system to use these different technologies that you may want to use as a data scientist. We'll move to the next slide. On from that, one of the things that's really kind of taken hold in the last, for 3 or 4 years is Jupyter Notebooks. So essentially, the way I once had this described to me was, these notebooks are essentially the Excel for the next generation. So when you look at them, they're a very manicured, very well structured set of processes around, how can you, identify, where your data is, how you need to transform your data, what do you need to create the model, how do you kind of train the model, and then how do you actually present whatever needs to be presented after that. So Google's got a couple of different options with regards to these notebooks. One is a publicly facing option, which is called Colab. So you can actually just go to colab.cloud.google.com, I think is the address. And that's good to kind of go and have a look at what is possible. We have a lot of researchers that use that day in, day out. The one thing you've got to be careful with that is a public facing environment. So if you're working on data that is, has some sensitivities to it, you probably don't want to use that environment. You want to use the environment that's more inside of GCP, that we can lock down, that we can control a little bit more. So if you're dealing with healthcare information, as an example, essentially what happens is inside of the user interface, you say you want to instantiate a notebook. We go and spin up in the background a set of containers and VMs that essentially power that notebook, and it allows for them to be scalable. So if you do want to do something where you need hundreds of cores for a short period of time to execute against that notebook, doing that on premise is a very difficult thing to manage. Doing that in the cloud using technologies like this, it makes it a lot easier. So you can drive towards research completion, I think, a lot faster just because the underlying infrastructure can ebb and flow depending on what your requirements are. So it's actually like this is proving to be very advantageous and interesting to the research community, just because of the ease of use with regards to notebooks. Now, notebooks aren't for everyone. You're going to probably find across the university that you're going to have some folks who like that VM approach, and then you have some folks who kind of do like the notebook approach as well. And we'll just move on to the next slide. And then you kind of get to the AI platform, which kind of opens it up even more broadly. The notebook element that I just spoke to is a subset of this. And this kind of allows for that kind of holistic platform where you can start looking at things like the AI hub, and I'll talk a little bit about that in a second. But how do you bring all your data sets together? Be it data sets that you've brought to GCP, or data sets that are public data sets that you want to leverage to kind of derive additional insights or deeper insights from your data. One of the good use cases right now is around COVID, and looking at the public data sets that we have on BigQuery around COVID. You don't need to go out and kind of get all that stuff together. You can just use BigQuery. That's all stored in one table, and then you've got your data in another table, and you can just start running SQL against that, or extracting that data for other particular users. So we're trying to make that interaction and the ability to kind of draw data sets together a much easier process for researchers. A lot of this also allows you to kind of monitor what's going on. So if you're finding that your model training is taking way too long, you could potentially just flip this to give it more resources, or allow for it to scale, or allow for it to auto scale, depending on what your needs are. Some of those things you need to be a little bit careful, because you need to keep costs in mind. There's a great paper we've got around a researcher at MIT who he leveraged 2.3 million cores to do some mathematical modeling, which allowed him to do this over the weekend, which usually takes months, but there was a cost associated with that. He was obviously a very well-funded researcher to enable for that, but it does give you that ability to kind of move around. And one of the other things inside of this, you'll see hopefully down the bottom there is an endpoint. We can allow for the model to be created and also presented to as essentially an API. So if people want to start kind of hitting the model for whatever reason, the reason is to kind of get an answer back, isn't it? Obviously, sometimes that can be kind of tricky to manage. And how do you do that? We have just a logical workflow where we instantiate that endpoint in a container and present it out. So you're just given a URI where you can kind of add variables to that URI and get an answer back based on what type of model that is. So again, as a researcher, you could get to a point where, okay, we've trained this model, we now need to test it. You've now got a very simple mechanism to kind of get it out into that testing harnesses or testing frameworks that you may have. Next slide. So the AI platform, I've kind of touched on, some of this, but just some of the other areas to kind of extract out from this, like some of the stuff around built-in algorithms. So we, as part of the marketplace, there are some elements that are brought in, but then there's also a solution which is called AI tables, which is super interesting in that it allows for models to be created using different frameworks, and then looking at the correctness of those models and comparing them, like using things like MXNet and different solutions, or XGBoost and things like that, and then kind of mapping them to try to figure out, okay, for this particular model that I've created using this framework, I'm finding that the response is much more positive than using one of the other models. So there's some really cool things that we've brought to this. So as you can, potentially look at a broader swathe of training harnesses that could get you to a much, more positive result. So auto like one of the things I'd recommend you do as part of the readings on from this is looking at AutoML tables, because that can also guide you into, then you can take what you learned from that and go to the deep learning VM and actually apply it there and tune it even more. Some of the other areas I've kind of spoken about here, but just to kind of roll onto the next slide. The workflow of this is also super interesting. Now in research, I don't know, I haven't seen as much of this because I tend to find that a lot of the research is there's a lot of ideation there, where things like Kubeflow and the AI platform can also be advantageous if you want to take this into a production or even things like commercialization. This can be really interesting because this allows for you to look at what you've developed. And I know there's a huge push on, around different universities here in Canada around the commercialization of research. These things can actually help kind of make that jump across into the commercialization of the product and turning it into something that's, product ready or product capable, production capable type solution. So, the ability to build, train, deploy anywhere. We're trying to, again, reduce that friction from the development environment so as data scientists can really spend their time honing, what their focus is and what they're trying to build. Next slide. The AI Hub Beta, so it'll probably, be released, I think it's early next year. But this is actually really interesting, both from a sharing resources inside of, the university, but also sharing resources from outside. How often do you bump into situations where you're chatting with someone and you're finding that they're, someone in the like field, and they're actually working on something very similar to what you've done, or they've developed something that's similar to what you've done that you could leverage to kind of move your research further. We're creating a catalog of different areas, like how do you do data extraction? Someone may already have a pipeline, a data pipeline that you could use for your development. So essentially you could cut and paste that into your environment. Is there a notebook that someone's published I've forgotten the acronym for the file, but is that available where you can kind of leverage that to, move or get you going a little bit faster. So it's very much, it goes back to this, Google's mentality around open source and looking to share, resources. We're trying to create a bit of a community and a bit of a public marketplace here, but then internal to your university, you can kind of block that out and just create things that are specific to your research group or the university unto itself. So as you're sharing resources again, so as you're not having to reinvent things across different and disparate groups. Next slide. So this is kind of just it's a bit of an eye chart, isn't it? But when you look at it, there's a whole bunch of things that we can kind of do, and it's all, a lot of this is built into the platform in a couple of different ways. We're trying to definitely look at the personas of the researchers and try to make sure that we have solutions that can deal with the deep neural network teams that are trying to optimize models from the AI perspective, but then also leaning over to the other side of you may have medical researchers whose background is not in AI. How can they kind of ideate and create and potentially start heading towards a more deeper involvement with regards to AI? This also plays into different users that are at play outside of the scientific community, like things like business analysts that could be as part of or integrated as part of the research teams, and then also end users. Goes to the point I made about the endpoints. If you wanted to test this with a small cohort or quorum of users, we're trying to make that easy as well. You don't have to go through hoops to kind of get the web servers all set up and externally facing IP and all that fun stuff. A lot of that we can just kind of create a workflow and step you through it. Things like the frameworks. I know some folks have their frameworks and they work on that consistently. Other folks do want to kind of bounce around a little bit to try and find goodness with that. We support pretty much all of the large frameworks that are out there. And then, yeah, the other things is around, development paths. How do we, that ML ops, the machine learning operations side of things, how do we make that simpler for researchers as well, so you don't have to worry as much about it? We can try and automate that where possible. Next slide. I think that's it. So I'm going to pause there and see if folks have some questions. I think we've got a little bit of time here, but